Hello students, welcome to the next lecture on the linear algebra. Today we will discuss about GATE 2018 papers about this linear algebra. Myself Dr. Harish. You can simply follow my YouTube channel and scan and join my WhatsApp group for the various discussion. There is a playlist of the GATE mathematics in my YouTube channel Dr. Harish, where you can find the PY questions of the GATE 2009 to 2023, PY question of the differential equations, as well as the PY question of the linear programming problem. Also, you have seen the complex analysis GATE 2023 complete solutions, as well as this GATE 2022 and so on. There is also one playlist called as the CSR UGC net, where you can find the complete solutions of the previous papers. So let's start with this video with the help of the shortcut tricks. So first question is question number 13. It is given to you. A is here. A, B, C are my real numbers such that F is my non-zero. Then you have to find the geometric multiplicity. So what is the geometric multiplicity of this 3 cross 3 is? That is 3 minus rank of A minus lambda I. That is my here. So where lambda is the largest eigenvalue of A. Now since A, B, C can be any real numbers, so for the sake of simplicity I can take A, B, C all are my 0, and F is a non-zero. I can consider this F as a 1, so that my calculation will be simple. Then your answer will be 2 0 2 0 3 0 3 0. Then clearly says that the determinant of A is my 0. Fine, you can clearly say determinant is a 0. What is the meaning of that? Rank of the matrix A is less than of 3. Fine. Now also you can see this is a 2 cross 2 minus, so it means which is a non-zero, so determinant of rank of the A is my 2. Once you can find the rank of the A is 2, once the determinant is 0, so 1, what is that? How you can find the other eigenvalues? That is not be there, because one of the eigenvalues is 0, so you can see 3 minus rank of the A is my 2, the difference is my 1, so this value is my, the largest geometric multiplicity of the largest eigenvalue is my 1, is a simple answer of this problem. Moreover, if you want to find the eigenvalue of this, you can easily find that this is a minus lambda I, one eigenvalue is 0. You can find the eigenvalues. You can see that trace will also be the 0. So definitely if this value is A, so what are the eigenvalues of this? If this value is alpha, then the other value will be minus of alpha. So since all are my distinct eigenvalue, so the algebraic multiplicity of the each eigenvalue is 1, so geometric multiplicity is also 1, is another way you can check about their answers. So right answer is my 1 is the correct option. Look at the second question. The dimension of the W1 plus W2. So that's a very simple, dimension of this plus dimension of this minus dimension of intersection. Fine. So what is the dimension of the W1? So W1 consists of the 3 elements, out of which there is, what is that? There is one relation between them. So it means I can replace as here. So the dimension will be my 2. Again there is a one relation between the x1, x2, x3. So the dimension is 3 minus 1, 2 again. How you can find the dimension of the intersection? So what is the intersection is? That is x1 is x2 plus 2x3 and x1 is 3x2 plus 2x3. So once you equate them, you will get x2 in terms of x3. Once you find the x2 in terms of the x3, I can substitute here. I can find x1 in terms of x3. There is no need to find what is the coefficient of the x2 and x3. We get only the objective quotient. So what is the meaning of that? So this pair is consist of the one variable, that is the x3. So the dimension is my 1. So what is the right answer? Dimension is my 3 is the correct answer of this problem. Look at the next one. V is the vector space of all the polynomial of degree less than or equal to 2. What is the basis of that? What is the basis? 1, x and x square. Then, so the dimension of this V, what is the dimension of this V is my 3. So if you define the mapping T, it must be of 3 cross 3, and the bases are my 1, x and x square. So firstly I can take P as my 1. If I substitute here, what is the answer is 2 plus 0. So the constant is my 2, coefficient of x and x square 0. If I take the second pair, that is the x, what is that? This is my 2x plus 1. So coefficient of the constant x 0. If I take x square, so it will be my 2x square plus 2x. So this is my 2, this is the 2x, this is my 0. Then the number of the non-zero entries of the Jordan canonical form of the matrix T. So you have to find the Jordan form. So how you can find the Jordan form? You have to find the eigenvalues. So that's very simple. What is the eigenvalue of this? 2, 2 and 2. So algebraic multiplicity of the 2 is my 3. Can you find the geometric multiplicity? That is 3 minus rank of a minus 2i. So what is the rank of the a minus 2i? So diagonal values are my 0. So it's a 1, 0, 2, rest values are 0. So clearly says the rank is my 2. So geometric multiplicity of my 2 is 1. So what is the meaning of that? Once the geometric multiplicity is my 1, so what is the meaning of that? If you define the Jordan block, and all of you know how you write the Jordan block, the diagonal entries are my eigenvalues, and the geometric multiplicity tell us that the number of the Jordan blocks of the eigenvalue 2. So it's a 1. So lower values are my 0 and the upper values are my 1, and here because geometric multiplicity is 1, so it has repeated only 1 times. So how many number of the non-zero entries? 3 plus 2, 5 is the right answer of this problem. That's a very simple target for this example. Okay, look at this another one. You have to find the directional derivative. What is the directional derivative? Is gradient into unit vector. Fine. So what is the gradient of this u? So if this is the u, then instead of the f it's a u. So what is the gradient of this? Partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z of this u. So 2x I cap minus 2j cap 8zk cap. So at this point, what is the gradient of this? So it's a 10 I cap minus 2j cap plus 0k cap. So this value is there. Now u is the unit vector. U is the unit vector. This is already a unit vector, so I can take this as a u. So that is my 3 I cap over 5 minus 4 over 5 j cap. If you take the dot product of this, so it's a 30 over 5 plus 8 over 5. So what is the right answer of this? Sorry, it's a k. It's a k cap. So it's a 0 plus 0. So it's my 6 is the right answer of this problem. That's a very simple question about this directional derivative. Okay, look at this another one. C is the real vector space of the continuous function. T is the mapping over here. Then the dimension of the range space of this. That's a very simple. If you remember that this kind of the is also called as the kernel. Fine. But there is no need of that. What will happen if I open this bracket? Is a sin A cos B fx plus cos A sin B fy dy. Now you can integrate over this 0 to 1. Now see, this is the integration of the y, so it means sin x is my outside. Whatever the remaining part is there, you can integrate it, you will get a constant value. So I can say this is my c1. Similarly, from here this cos x is outside, the remaining part is here. If you integrate, because the limits are my finite, if you integrate, this is my here. Now what is the dimension? How many constants are there? There are the 2 constants, so the dimension of this is my 2. Why? Because you can see what is the basis of this? Basis is my sin x and cos x. The dimension of this is my 2 is the right answer of this problem. Okay, look at this another one. A is any number which lies between -1 to +1. Be such that the quadratic rule is my here is exact for all the polynomial of degree less than or equal to 3 x square and x cube. Fine. So that's very simple. If I simply take f of x is my 1, what will happen? This integration will be my 2, right hand side is 1 plus 1, it's a satisfied. F of x is my x, right hand side is a 0, left hand side is minus a plus a, again 0. If I take f of x is my x square, left hand side will be my 2 over 3, right hand side is a square plus a square. So clearly says if you solve them, a square is 1 over 3 and your target is to find 3a square. 3a square is my 1 is the right answer of this problem. That's again a very simple target about this problem. Okay, let M2 is the vector space of the 2 cross 2 real matrix over the R. Define a mapping S from M2 to M2 defined by 2x plus x transpose, then the trace of this S. This is similar to this example of this. Whenever there is a transformation given to you, you always start with the basis. So again I can start with the same rule. So what is the basis of the M2? What is the dimension of this? What is the dimension of the M2? It's a 2 cross 2, that is a 4. So what are the basis of this? If I call this E1, that is a 1 0 0 0, fine. Second basis is a 0 1 0 0, third basis 0 1 0 0, and the fourth basis is my 0 0 0 1. So I can substitute this value as here. Firstly we can take here, then what is my this 2x plus transpose, so it will be 3 0 0 0, fine. What is that? Second, when you take this as here, if you multiply by 2 and transpose, if you take transpose it will be here and this will be this. Third, when you consider here, if you double them and then transpose, so if you transpose this will be here and double will be this case. And what is the last case is, if you double them and transpose it will be my 0 3 0 0. Then you can write the matrix. The first pair is my E1, E2, E3, E4. Now how you can write this? It's a 3 times E1, rest pairs are my 0. Second is, it's a twice of E2, and 1 times of the E3, rest values are my 0. E3, 1 times of the E2, 2 times of E3, 2 times of the E3, 1 times of the E2 is my here, and this is 3 times of the E4, fine. Now what is the trace of this? Trace is nothing but my sum of the diagonal values. So the right answer is my 10 is the right answer. Remember always, whenever there is a whenever there is a vector space and some transformation is given to you, you always start with a basis and you can write the matrix and then talk about this answers. Okay, look at this another one. R cube is the usual inner product space. D is the distance from x, y, z. This is say 1, 1, 1 to the subspace of the 1, 1, 1 and here. What is that? It's a span of this. So if I consider this is my span of 1, 1, 0, 0, 1, 1. How you write this span? That's a linear combination of this, fine, where alpha and beta are my real numbers. So what is that? This is alpha, alpha plus beta, and it's beta, fine. Now your target is to find the distance of this to the subspace. So I can find the distance. It's a square root. I can take as a square, alpha minus 1 whole square. This from here, alpha plus beta minus 1 whole square, and of this. Now your target is always to find the minimize the distance so that you can find the value of alpha and beta. So I call this is say h. So your target is to minimize, this is 0 and this is 0, fine. So what is that? It's a twice alpha plus, it's a twice minus 1 is equal to 0. From here it's a twice alpha plus beta minus 1, it's a twice beta minus 1 is 0. So clearly says that from these two equations, what you get, this value is equal to this, that is alpha is equal to beta. So how you can find the value of this? I can substitute here. So it's a 2 will be cancelled out. So it's a alpha minus 1. It's a double 2 alpha minus 1. So alpha will be my 2 over 3. So alpha and beta both are my 2 over 3. So what is my point? First point is 1 comma 1. This is the point. And what is this point is? Alpha is my 2 over 3. It's a 4 over 3. And beta is my 2 over 3. So find the distance. How you can find the distance is a simple distance formula. So it is 1 over 3 square plus 1 over 3 square plus 1 over 3 square. So what is the right answer is 3 over 9, 1 over 3. This is my d square. So d square is my 1 over 3. So 3d square is my 1 is the right answer of this problem. Okay, look at this another one. What is given to you? A matrix A is given to you as I9 minus twice of this. Fine. Lambda and mu are the distinct eigenvalues of the A. So you have to find the eigens value of the A. So that's a very simple. What is the eigenvalue of this? It's a 9 times 1 minus twice. What is the eigenvalue of this? Our target is to find the eigenvalue of U transpose of U only. Once you know that, we can subtract that. Now what is the U transpose of U? U is given as this value. It's a 1, 2, 3, 6, 9. It's a 9. So this is clearly a 9 cross 9 matrix. Since all the entries are my 1, so if you U transpose 1 by 3, 1 by 9, all the values are my 1, 1, 1 and so on. Fine. So clearly says the sum of the each row is my 9. So one eigenvalue is 9 divided by 9. Or you can see here, one eigenvalue is 9. Determinant is a 0. So what is that? The rest of the elements. How you can see? I can find the geometric multiplicity of the 0. So it's a 9 minus rank of A minus 0I. What is the rank of the A? What is the rank of the A? It's a 1, because rest of the elements all are my 1, 1. So 9 minus 1 is 8. So geometric multiplicity of the 0 is my 8. So 0 is written as a 8 times. And this is a 1 times of here. So what is the eigenvalue of this? Eigenvalue of this is my 1, 0, 0, 0 up to 8 times. So that's over. So what is the eigenvalue of this? 1 minus 2 is my minus 1, 1, 1, 1 and here. So lambda and mu are the distinct eigenvalue. So lambda is here, mu is this. What is the difference between them? Is my 2 is the right answer of this problem. That's a very simple about. You have to write this matrix, find the eigenvalue, you will get as of here. You can also find the geometric multiplicity of the 9. You can see it's a 9 minus rank of A minus 9I. If you take A minus 9I, it will be my minus 8. It will be minus 8, minus 8 and minus 8. Clearly says the rank of this is my 8. So it is a 1. So geometric multiplicity of the 9 is only 1. So the right answer is my 2 is the right answer. Okay, look at this another one. If A is a 3 cross 3 matrix, the 3 solution of the differential equation is here. The sum of the diagonal entries of the A, that is nothing but the trace of the A. Fine. So what is the meaning of that trace of A? Sum of the eigenvalues. So it means your target is to find only for the eigenvalue. So remember, as I told you earlier in my previous lectures, if this is the solution, how you can solve this one? You can find the eigenvalues. You can find the eigenvalue of this A. Say it is a lambda 1, lambda 2 and so on. Then how you can find the solution is? How you can find the solution? That is a C1 e raised to power lambda 1 t into eigenvector x1 C2 e raised to power lambda 2 into t, x2 is the eigenvector and so on. Remember, this x1, x2 are my eigens vectors. Fine. and lambda 1 lambda i's are my eigenvalue. So if you look at that, this is the solution given to you. So coefficient of the t, look at that, the coefficient of the t is my eigenvalue. Fine. So look at that, what is the coefficient of the t? Is a 1. Coefficient of the t is my 2, it's here. Coefficient of 2 is a minus 1. That's all. So what is that? These are my eigenvalue. So what is the sum of the eigenvalue? Sum of the eigenvalue is my 2 is the right answer of this method. There is no need to solve the problem, just look about the basic concepts, you will get the answers in a very simple manner. So I hope you can simply learn all the question of the GATE 2018 mathematics in a very simple manner. We will see the next lecture on the GATE 2019 questions. Till then, you can simply scan and join my WhatsApp group for the various discussions part. Till then, I hope you can like, share and comment on my video. Best of luck students. Happy learning.